Now, before seeing what is meant by allocation, memory allocation techniques, we will first see what is meant by an address space. Okay, what is meant by an address space? See, address space means it is a collection of addresses. Okay, in case if I have a set of addresses, say address 1, address 2, address 3 and all, I say the set of addresses is address space. Okay, so RAM is nothing but a collection of addresses, right? A RAM is a collection of words, we know that, and within every word will have an address. I have told that, and so our RAM is having a collection of addresses. Okay, I can say this as physical address space. Okay, physical. See, address space means collection of addresses, and the addresses of all the addresses of RAM are also called as physical address space. Okay, see, in RAM what we do is we actually place processes, right? We know that how a program is created and how it is being placed as a process inside the RAM, we know that. So inside our RAM we place processes. A process is nothing but a program, data and all this, right? It is a collection of data part, code part, all this we have seen it, right? Static variables, global variables, all this. So this is what we mean by a process. And even our process will also have a collection of addresses. Okay, see, these addresses will be starting from 0, 0, 1, 2, 3, right? Even these addresses will also start from 0, 1, 2, 3 and so on. Okay, so even our process will also have a collection of addresses. Okay, we also say this as address space. Now the collection of addresses of the process, it is also called as logical address space. Okay, it is also called as logical address space. So the set of all addresses of the inside our memory, in the memory, is also called as physical address space, whereas the set of addresses in the process, it is also called as logical address space. Okay, now why this address space is actually important is in order to understand what is meant by contiguous allocation. Now what is meant by an allocation, memory allocation? See, we are trying to place processes or data inside our RAM, right? We are going to place it inside our RAM. That is what we mean by allocation. Okay, placing the processes or data inside the RAM is also called as allocation. Now there are two ways of allocation. One is nothing but contiguous allocation, another one is nothing but non-contiguous allocation. Okay, now what is meant by contiguous allocation is set of all addresses in the address space. In case if the set of all addresses in the address space of a process, which means set of all addresses in the logical address space, in case if all of them are present in contiguous addresses in main memory, we say that as contiguous allocation. I know you didn't understand it exactly. See, our process is having a set of all addresses, right? Our RAM is also having a set of all addresses. Now we take this process and then we place it inside the RAM, right? Now in case if we play, for example, if we are placing this address process P1 from here to here, okay, this is what process P1. Now P1 is actually placed in contiguous memory locations, right? All the addresses of process P1 are actually placed in contiguous addresses of our RAM. For example, it is having an address 4, 5, 6, right? All these are contiguous addresses in the RAM, and this process is also having, let us assume this is 0, 1, 2 and so on. Okay, these are addresses of our process, these are addresses of the RAM. Okay, so all the addresses of our process are all placed in the contiguous addresses of our RAM. Okay, so we say this as contiguous allocation. Okay, in case rather than placing the process P1 like this, we could, in case if you have placed process P1, some part of process P1 over here and some part of process P1 over here. Okay, it is a non-contiguous allocation. It is not a contiguous allocation because all the addresses of process P1, okay, let us assume 4 address 0, 1, 2 of process P1 are placed here, 3, 4 are placed here. Okay, here this is 6, 7, 8, 9. Okay, so all the addresses of process P1 are not placed in contiguous addresses of RAM. Okay, we have left some gap. So clearly this is a non-contiguous allocation. Okay, see, process P1's address 0, 1, 2 are placed in 4, 5, 6, fine, in the RAM. Whereas the next address should be placed in 7, but rather we are starting it from 8, right? So process P1 is actually all the addresses of process P1 are not placed in contiguous addresses of our RAM. So it is nothing but a non-contiguous allocation. Okay. So fine. Let's see the classification of contiguous allocation, non-contiguous allocation. Okay, in a bit more detail. See, it is just a rough idea. What is meant by contiguous allocation? All the addresses of our logical address space are placed in contiguous addresses of our physical address space. Okay, that is what we mean by contiguous allocation. Whereas in case if all the addresses of a logical address space are not in contiguous addresses of physical address space, we say that as non-contiguous allocation. Okay.